Hello students, welcome back. So our last topic was problems based on number theory. Now in this topic, that is distribution of alike objects, we will see how different objects which are alike, by alike I mean which are of same kind, are distributed among different persons. So there is one beggar coin theory that is very famous, so we will see that in this slide. Okay, so let's have a look. Let us look at the distribution of alike objects. So if I want to distribute n identical coins among p different persons such that each person get any number of coins, then the total number of ways of doing so will be given by n plus p minus 1c p minus 1. Now let us see the proof of this through an example. Suppose if I have 6 coins and if I want to distribute the 6 coins among 3 persons that are R, S and G, then what basically I will do is I will insert 3 minus 1, that is equal to 2 false coin. Now these are false coins, and the purpose of this false coin is, if I insert one false coin here and other false coin here, then this false coin will act as a partition wall. This false coin will act as a partition wall and it will divide these 6 identical coins into 3 groups. So R will receive 2 coins, S will receive 2 coins and G will also receive 2 coins. Suppose if I had inserted false coins like this, then in that case again this false coin will act as a partition and R will receive 1 coin, S will receive 3 coins and G will receive 2 coins. So in all there are 6 identical coins and 2 false coins. So total there are 8 coins, and out of these 8 coins I want to choose any 2. So total number of ways in which 6 identical coins can be distributed among 3 persons will be given by 8c2. Now let us see the proof of this formula. Now suppose if there are n identical coins, and if I want to distribute this n identical coins among p persons, then the total number of ways of doing so will be given by coefficient of x to the power n in the expansion of each person can receive either 0 coin or 1 coin or 2 coin or n coin. Now again the person 2 can receive again 0 coin or 1 coin or 2 coin or n coin, and similarly this will be repeated for all the persons. So this will be repeated p times. So the coefficient of x to the power n in the expansion of x to the power 0 plus x to the power 1 plus x to the power 2 up to x to the power n whole power p. So the coefficient of x to the power, if I use the binomial theorem, then this will be equal to 1 minus x power n plus 1 divided by 1 minus x power p. So the coefficient of x to the power n into the expansion of 1 minus x power n plus 1 power p into 1 minus x power minus p. So there will be no coefficient of x to the power n into this. So directly I can say that coefficient of x to the power n into the expansion of 1 minus x to the power minus p. So the coefficient of x to the power n into the expansion of 1 minus x to the power minus p will be given by n plus p minus 1c p minus 1. So these are the total number of ways in which n identical coins can be distributed among p persons. Now let us see the type 2 of this problem. The total number of ways in which n identical items can be divided among p persons such that each receive at least 1. Now all the persons should receive at least 1 coin. So the total number of ways of doing so will be given by n minus 1 c p minus 1. Let us see an example on this. Suppose if I want to distribute 7 identical computers among 3 persons, that is R, S and G, then the total number of ways of doing so will be given by 7 minus 1 c 3 minus 1, which is equal to 6c2. If you have any doubts, then you can log into www.askIITians.com and then you can click on the discussion board, which will redirect you to this page where you can see Ask Expert on the right hand side. From here you can select the category of the question and you can post your question here for free, and the experts at Ask IITians will answer your question within 24 to 48 hours. So students, we have seen how n alike objects can be distributed among various persons. So our next topic for the next video will be summation of numbers, and we will also look at grid problems. So stay tuned till then. Have a nice day. Thank you.